OpenCV and MobileNet version 2. Our speaker for today is Nikhil Kashyap. So before we dive into the webinar, let me give you a brief about what we do and what are our services. We started Sarak Technologies back in 2014 as a consulting company headquartered in Singapore. In 2018, we started training in emerging technologies such as blockchain. In 2019, we started with artificial intelligence and machine learning. Last month, we started a webinar series, which is going to be a 50 webinars starting from, we started on 15th of August, and then we continued on 22nd August, and this is our third webinar in the series. As I already mentioned, we are headquartered in Singapore, and we also have presence in India and United States. Apart from webinars, we also provide mentoring, group mentoring, and one-to-one mentoring to candidates who want to transition their career from career to AI or machine learning or any data science related field. So we started this on the webinar series in August. The first one was taxi fare prediction in New York. And on 22nd August, we did a webinar on build a contextual chatbot using Rasa NLP platform. So we have three major tracks that we conduct our webinars on: NLP, machine learning, prediction algorithms, and computer vision. So last two webinars were on machine learning prediction algorithm and NLP. Today's topic is going to be on computer vision. Again, on 12th September, we have another webinar coming up that's going to be a pricing analysis of Melbourne housing market using linear regression. I've already shared the webinar link with you on the chat session. If you are interested in machine learning track, please go ahead and join. If you want to get in touch with us, you can write to me at santosh@novalabs.com or Nancy or to nancy@novalabs.com. Or you can, if you want to reach out to any other member, you can, or any other topic apart from training and mentoring, you can also write to us at contact@novalabs.com. So let's move ahead with the webinar today. Our speaker for today is Nikhil Kashyap. Nikhil is an experienced machine learning engineer who has provided enterprise-wide transformation programs and solutions. He has empowered businesses to create, deploy, and scale by providing end-to-end AI platforms. His goal is to bring research ideas to production and help companies to create practical business value through AI. Over to you, Nikhil.
Yeah, thank you, Santosh, for the introduction. Hello, everyone. Can you guys hear me? If you can hear me, just say yes in the chat box. Okay, cool. Okay, yeah. So, hello, everyone. I hope you all are safe and doing well. I am Nikhil Kashyap, a machine learning engineer. I have experience building various statistical and deep learning models for various businesses. I'll be conducting today's webinar on Rock-Paper-Scissors-Spock-Lizard game using OpenCV and MobileNetV2, and I'll be coding along the way. Welcome to the webinar, guys. So we'll directly, dive into the coding. So can you guys see my screen here?
Yes, sir.
Oh, okay, yeah, thanks, man. Thanks. Okay. So this is what this is the Jupyter notebook, what I'm using here. So let's start by importing the OpenCV package. So import CV2 is the command is the code for importing the OpenCV package. OpenCV is a powerful Python library mainly aimed at real-time computer vision problems. So once I have it in place, so the thing is often we have to capture live stream with camera, right? So OpenCV provides a very simple interface to this. To capture a video, all you need to do is create a video capture object. So I'll say is equal to cv2 dot video capture of 0. All right. So its argument can be either the device index or the name of the video file. Here I'm using the device index because I'm using the webcam. Uh, Hence 0. If we have an extended camera, like a secondary camera attached to your computer, then you pass 1 here, and so on. Right. So we have this here. Next, what we'll do is while while true is equal to. So um, here, the object whatever we have created dot read, reads the um, uh, the frames from the webinar feed, and it returns a boolean value or true or false. If the frame is read correctly, it will return true, else false. uh, that's why we are capturing here the return here and the frames here. After this I'll show you what I'll print return, and we'll see if it's true or false. Next, what you can do is cv2 dot frame. What we are doing here is just displaying whatever we have collected in the frame, and we are displaying it back here. And you can write whatever you want here, like rock paper scissors or anything. I'm just using frame here. You can do whatever you want there. So once you have it there, so what I'll say is uh, cv2 dot weight key of 1 is equal to order of q. All right. Say because we are in the inside the infinite loop, so we'll break out of it. So what I'm doing here is um, you the weight key here. We are just setting the queue. If you just press q, it will break out of the infinite loop. That's what we are doing here. So here weight key cv2 dot weight key of 1 will give you the 32-bit integer of the value of the queue, and odd of queue gives you the unique code. If they both match, then that's what I'm saying. If they both match, then break out of the infinite loop. Once you have this, let's um, release the sorry, release the object because to free up the memory. And what I'll do is cv2 dot destroy all windows. So what I'm doing here is I'm destroying all the windows so that this to is to just to free up the memory whatever have been utilized here. So if I run this, Uh, ah, I know. This is what you get. So this is the feedback what you are getting. So we are reading the frames, and this is the feedback what you get. I'm sorry you'll have to see me a lot today. Please bear with me here. Um, there is no object release, so let me just process some. Oh, I'm really sorry about this. Right. Finally. So once we have this, so you get the basic understanding of what we did here, right? So on top of it, what we do is we'll start adding few more features on top of it, so that we are ready to capture all the data required. So I told you, say print. See, the frames or whatever it has read was read properly, so that's why it's returning true, else it would return false. So next, what you can do is, I'll say, just some random number. Here, you know, we'll be getting the width and of the screen and define width of the screen and define this box width. You'll see why we are doing this. So what I'll say is, and not of 3, right? So once we have this, so this object with dot get of 3 gives you the width of the frame. If you pass 4 here, you'll get the height of the frame. So we need the width. You'll see why we are doing this. Once you have that, let's define something called region of interest. So what we are saying to OpenCV here is concentrate only on the region we have defined. If you didn't follow what I just said today, I'll show it to you, right away what it means. So what I'll do is cv2 dot rectangle. I'll pass the frame and I'll pass the width. All right, and then okay, I'm sorry. Pass the I need to pass the coordinate of the um you know just hold on. I'll just show you what exactly that we are doing here. This is just the XY coordinate of the starting of the rectangle which I'm about to draw, uh, and this is the the ending coordinate of the rectangle. So what I'm saying here is, this is in the form of BGR. So it's draw me a red box in this coordinate, whatever I'm passing. This will be the starting coordinate, and this will be the ending coordinate of the box, and this is the color I'm specifying, and here is the thickness, um, the of the edges, of the edges of the rectangle. So what you can do here is, if you run this, uh, just name it to rename it. Right. So this is what we were doing. So what I'm specifying here was the starting coordinates and the ending coordinates of the box to be drawn, and the thickness. What I'm saying is give me to, oh, that's just the values for this thickness, and uh, draw me a red box. So what I'm doing here is I'm raising my right hand, but it's showing as if I'm raising my left hand here. It's not mirroring properly, so we'll just fix that right now. So what I'll do is, So what so what I'll do is I'll you know frame is equal to I'll flip, I'll pass the frame, and what I'm saying here is I'll flip the frame laterally. All right. So that's what I'm doing here. So you can see it right now. Um, yeah. So I'm raising my right hand. So this will be paper, rock, scissors. So I can, you know, it's mirroring properly. So it's easier for me now. So what I can do now is, I'll say something called as find a variable. So what I'm saying is, collect this number of variables for me. This number of samples for me. So that's what number of samples this is for. And the other thing is, say trigger equals, it's a flag, whatever I'm defining here. It just when to start the recording, and we'll also define the variable counter um, to count the number of samples we have collected. Next thing what we need is, let's do, yeah. So what I will say here is, now we'll write a small code snippet to capture the samples. If trigger, you know, this is equivalent to if trigger is equal to true. So if you don't get, if you don't get it, what it means. So ROI is the region of interest for us here. So I'm saying frame to box size, comma, minus box size. So what I'm doing here is I'm slicing the whole frame to only the region of interest. If you print the frame, you'll see it is the RGB values of arrays of array. I'll just can see, yeah. So this is the RGB values of arrays of array. So that's what I'm doing here. I'm just slicing it from the values from here, whatever I have defined here. This is y2, this is y1, y2, y1, y2, and x1 and x2. I'm just slicing it. Um, so region of interest is what you have defined here, and now we need to, of course, increment the counter, right? So we have defined if else, what it should do. If trigger is true, collect it. Else, what we'll do is, let's put text, all right, on the screen saying press R for rock, press P for paper, S for scissors, N for nothing. All right. So once you have put defined the string text here, so now let's put it on the screen. So what it says, cv2 dot text, will pass the frame here, and of course the text, and these are just the this is the starting coordinate of the text, and I'll say give me so I think it's font Hershey plain. Yeah. So this is just the font, whatever here I'm specifying, and this is the again the thickness, and again the color of the text, and this sorry, this will be the the font scale, and this will be the thickness. Um, I think we have, a thing here. We'll just run once and see. Yeah. So the text, whatever here is, we have defined there as being printed here, and we have everything here in place. So all we need to do here is uh, add some more code to actually collect the uh, actually collect our samples. So I told you what this means. I told that I'll show you guys what it means, right? So let me just say, let this be true, and yeah, here. So this is a region of interest. So the rest, whatever you were seeing before, is noise to us. We don't need it. So this is a region of interest, and we are interested only in this region. And if you can see here, um, you know there is a our red line, the text box here. We don't have any interest in that. So let's just remove that. So what I'll do is I'll add some padding to it. I'll say I plus 5. If I run again, yeah. So that red box is gone. So we have a clear image now. So if we can capture, uh, you know we'll have a better image now. Um, so once we have this, we said press R for rock and P for paper, S for scissors. Now we know that magic won't happen if we just just press those keys, right? What we need to do, what we need here is to actually write the code about if I press R, what it needs to do, right? So let's dive into it. But just before that, we have already defined what it needs to do when we press Q. Let me just rewrite it a little bit, and I'll say this as um, if I'll just assign this as K and say K is equal to yeah. So what I would, uh, do you agree with the logic here, right? It makes logical sense. What I have written is the same thing what I had before. So just based on this, what we'll do is let's write for rest of the things, what it needs to do when I press uh, R, and when I press S and all the other stuff. Just copy paste that, and so if K is equal to R, so we need to check that uh, trigger is equal not trigger, because initially our trigger will be false, right? So what I said here is if trigger is equal to true, only then this executes. So we need to flip that flag. So that's why trigger, we are just assigning, we are if all the not and or gates. So we are just flipping from false to true. That's what I'm doing here. Um, so I'll also define a variable class name is equal to rock, all right, and an empty list to collect the samples. I don't want this to break, so I'll do the same thing for um, scissor. I'll also laser, do the same thing for paper, and do the same thing for, because we need to define nothing also, right? So nothing and nothing. So we have things here. So I'm saying um, when I press R, for all the sample, associate a class name to it as rock, and you know um, so that we know which image is rock and all this stuff. So what we have here is we have almost everything here except one thing. Uh, we captured the class name and and the samples, but we never annotated them, right? That's we didn't say this image belongs to rock and this image belongs to paper and so on. So let's fix the two, and we'll be good to collect the data. What we'll do is we shall append the region of interest and class name to the list of to the list with the selected class name. What I'll do here is we have a region of interest here, and what I'll say is use something called eval class name dot append with a region of interest name. That's what I'm saying here. So after this, so let's put text to count our number of samples to so collected samples of so say format of class name comma class name comma counter. Yes. So we have this. We'll run it, and oh, I'm sorry. I should have changed region of interest. We want the frame. Yes. So we have it here. So when I press R and hold my hand as a rock, so it will start collecting. But just before that, we have um, a small thing to add. So, so we haven't told, we are incrementing the counter, right? But we haven't told what to do when it reaches the total number of samples it needs to collect. So we'll just add that, and I think then we'll be good to go. So what I'll say is if counter is equal to number of samples, because what we were doing here is we were setting the trigger from false, which was initially to true, so that it enters this if loop to collect the data. So once it collects enough number of data, we need to flip the trigger back, right, to false. So that's what we are doing here, and we need to reset the counter also. So say counter equals 0. So let's go. Yeah. So let's start collecting the data. Now I'll plus R. Oh, wait a second. Um, I'll just quit this. Sorry. Um, Oh, I'm really sorry. Bear with me. One second, I'll just stop sharing. See. Yeah. Oh, I'm really sorry, guys. You know, I just messed up somewhere. Okay. Yeah. It's fixed now. So what I'll do is, yeah, we have it here. So we have our region of interest here, and I'll press R. So you can see the all the counter going there, and let's get some data for paper and for scissors. Okay, and let's take some. Right. So we have all the data, already here. So we'll just visualize, say, import plot lib dot replot as plt. So we'll see what what are the import numpy as np, and we have a number of. So let's now set the figure size. Um, let's set to figure size is equal to 20, and for 8. These are just some self-explanatory code. So I'm just visualizing this, whatever I have collected. So I'm just putting into the loop and saying that display all these things for me. So what I'm doing here is I'm just randomly take some images and from randomly select 5 images of every class and print it to me. That's what I'm saying here. I will index in index star calls. Why is this? Oh, that's what we are iterating here. And I, so 0 to yes. So it took the random images and it just of every class and 5 random images from every class, and it just printed. So we are pretty sure that or it has the OpenCV has did the done its task properly. So it has read all the images, whatever we wanted. So now what we'll do is we'll get into, this is the starting of the model building of, this is where we are getting a slightly, we're getting into the neural networks before training the model. So what I'll do is I'll import, before that I'll say, um, for what I will do is I'll separate because what we did here is, yeah, this, what we did here is, we said, this image corresponds to this class. So what we are doing is we are separating that, and we are putting rock labels is equal to uh, not, and un- image. So we're just separating the images and its labels, and 0. Okay. Um, right. So if you can see here, rock labels, it contains all the rocks, and the label and rock images will contain all the images of the rock. So there are various ways to do this, even more efficient ways to do this, but let's take a simple approach for this webinar. So I'll just copy paste it and do this for paper. And same thing for scissor. Scissor, and nothing. So will be, oh shit, okay, I'm sorry. Um, yes. So what I did here is I separated all the labels and images, and put it into a list. What I'll do here is, after, let's combine everything. I'll say labels is equal to rock label plus paper labels, right? Plus uh, oh, okay, fine. Um, and we'll put all the images to into another array. Let's say rock images, paper images, nothing. Okay. Oh, huh. Um, okay. I'm sorry. So I need to define this also. Yes. So once we have everything separated, so we have our labels and our images. So it's easier for us to uh, you know um, train for our model. So if we can just print comma of images, let's see, 400 and 800. Oh, okay. It's fine. So we have that much labels and that much images. Um, so what we can do is we'll normalize the images by dividing it by 255 because all the RGB values are 0 to 255. So we'll just divide it by 255. So it will fall between 0 and 1. So that helps our training. So what I'll say is input array images float divided by. Yes. So once we have that, so what I'll say is as scikit-learn processing uh, import label uh, encoder. All right. So I'll just create an object of label encoder. So what we'll do is we'll convert what we have, the categorical variables of the labels, that is the rock paper scissor and nothing. We'll convert that into 0 1 2 3. All right, so that's why we are doing this. Now labels is equal to, we'll just reuse the variables, and I'll say transform of labels somewhere else. Huh. Uh, oh, okay. I'm sorry, guys. I just need to take the um, you know the images again because we have a problem there. So what I'll do is, please bear with me here. We'll just take the images quickly once again, and we'll start with the rock. And we have a rock here, and we have our paper here, and we have our scissors here. Yes. So we'll just see print length of um, oh shit, I know. Uh, just because what's happening here is I'm using the append, and it's keep on appending for because of the previously trained images. So I'll just restart. Yeah, this is most of your everyday coding what you guys need to do. So yeah, sorry. So we'll just quickly go for the rock. Yes, and we'll go for the paper. Yes, and scissor, and okay, we are done. Um, Yes, it will be fine now. I really hope it will be fine. Oh shit. Uh, 1 second. I'll just stop sharing and. Um, really sorry, guys. Just bear with me here. Ah, okay. Um, welcome to programming, right? The problem was I didn't normalize the images properly, so that was the problem here. So we have, you know, um, we have everything here. So we have our labels here. So I'll show it to you what it does. So, rock is 2 and paper is 1 and scissors is 3 and nothing is 0. So if you're wondering why it took those numbers, it's because, it maps alphabetically. So that's what it has happened here. Once we have it, what I'll do is I'll say servflow dot errors dot utils import. So what I'm doing is I'm doing something called one hot encoding. So what it will do is zero will be 1 comma 0 comma 0 comma, and 1 will be 0 comma 1 1 comma 0 comma 0 and so on. So we have these things will be encoded into arrays like this. So say labels equal uh, to categorical, sorry, here, to categorical of equals comma 4, right? Because we have 4 categories. So uh, um, oh, spelling. I'm sorry. Huh. Okay. Say, what did I import here? Oh, I have it here, right? So I'll just yeah. So we have our labels encoded into like the arrays, and what we'll do is we'll split our data set into test and train. To do that, I'll say I have imported import um, train x comma x train y is equal to um, train test split images comma labels comma test size is equal to, I'll say so 75% will be the training size and the 25% will be the test size, and random state for every 50 images it just shuffles and takes other 50. So that's what the random state is. Yes. So we have our training and testing, and just clear the RAM. So because we have all the images here, um, so what we'll do is we'll directly dive into model building now and import all the necessary packages. So I'll say tensor load as tf tensor flow dot models import comma one model and layers import one second guys, I'll just plug in. Okay, we need the dropout and we need pattern something called global average QD interactive, right? Okay, now what else do we need? So flow dot optimizers. We need the okay, so we have everything in place. So I'll say image put comma image height is equal to 224 comma 224. Ask me why I'm choosing 224 comma 224. I'll show you MobileNet. Um, not this. Yes. Right. So it says the input shape has to be 224 comma 224 comma 3. So that's why the image width and image height should be 224. That's what I'm saying. That's what I'll pass on now, and I'll say create an object mobilenet is equal to tf dot dot application. Sorry, mobile on net. So I'll say input shape is this, and it's a free. So what I'll say is include tops equals false. What does this mean is I'm doing something called transfer learning. So the top layer will be frozen so that we can train on that. And I'll say, and MobileNet is trained on ImageNet. So I'll say just borrow the weights from whatever it has been trained so that, I'll train on top of it. Okay, I'm sorry. Let's include shit. Oh, okay. In the meantime, so let's continue with net dot trainable. It's just downloading if you're wondering what's happening here. So sorry. False. We'll just freeze the whole model, and I'll say so what we'll do, what we are doing here is these are like these standard steps. So what I'm saying is we'll take the output feature maps from MobileNetV2. That's what I'm doing here, and what we'll do next is, yes, we'll do the global average pooling 2D, which we have imported from here and pass X to it. So if you guys are wondering what this is if you don't know what a global average pooling is, to give you an intuition, global average pooling, are used to minimize overfitting by reducing the total number of parameters in the model. Similar to max pooling layers, global average pooling layers are used to reduce the spatial dimensions of three-dimensional tensors. If you don't know what max pooling is, you can read about convolutional neural networks. But for this webinar, we can think about global average pooling as which reduces multi-dimensional input to a single-dimensional vector. If you still didn't follow what what I'm telling us, so you can say as np dot array, um, say 1, 2 and comma. So this is a 2 x 2 matrix, right? So I'll say, yeah, this is what is happening. But not exactly this. It's completely different. But just to give you an some intuition and understanding. So from multi-dimensional input, it's reducing it to a single dimensional vector. That's what is happening here. Uh, you can, instead of global average pooling 2D, what you can also do is you can import we have imported flatten, right? So here, so what we can also do here is we can say x is equal to name equals flatten, and we'll just say of x. So both does the same thing. For this, I'm just you can I'll share the notebook, and you can go ahead and try yourselves to see which one is better. But for this, I'm just using global average pooling 2D. Um, so what we'll do is we'll use dense layer, and with 128 units, and let's say activation equals value, and we'll pass our x here. And next is we'll use the dropout. Let's keep it to like 20%. Yeah. Then now we shall construct the model or dense here. Predictions. Here, dense defines the dense layers in the model. The final layer will contain, the four output units, right? Because that's the number of classes we have. Rock, paper, scissors, and nothing, right? So, and for the activation, we'll use um, softmax, right? And then we'll construct the full model. So I'll say model is equal to. So what this model does is it groups the layers into an object with training and the inference features. So I'll say input is equal to mobilenet dot input, and output is equal to not inputs. Huh. Oh, sorry. Yes. Oh, okay. Uh-huh. just the syntax errors. Don't worry about it. Now we'll check the number of layers in the model. So we'll say model dot layers. So there are like 91 layers in a model. So what I'll do here is I'll say model dot compile. So what once you have created the model, you can configure the model with losses and metrics using model dot compile. That's what doing here. I'm using optimizer is equal to, I'm using Adam optimizer, and with the learning rate is equal to 0.0. You can play around all these things. It doesn't matter. Um, and loss equals historical cross entropy. Um, you can use, or you can just use binary cross entropy and see how it performs, and also you can say accuracy. So we have our model compiled here. So what is it? From flow dot pre-processing dot image import image data generator. Okay, and I'll just specify the epochs. I'll say give me like 15 epochs, and batch size equals 20, and data gen is equal to image data generator. So I'll explain this to you in a while. So I'll say rotation angle, rotation. I think rotation range is equal to 30, and zoom range is equal to 0.25, and uh, width shift range equal 0.10, and height is equal to, also say 0.10, and range equals, let's say 0.10, and horizontal flip equals, let's say, yeah, I think that's enough. Okay, so image data generator generates batches of tensor image data with real-time data augmentation. So rotation range is, I'm just telling it, give me plus or minus 30 degrees of rotation for every images. Zoom range, it's self-explanatory. Width shift range, height shift range, and shear range is how the image should be tilted. You can think about it like the opening scene of Star Wars, like the text scroll. The long time ago, in a galaxy far, far away. That comes right in the opening scene. So that's what the shear range is. Horizontal flip, I'm setting it to true because you can use whichever hand you want. So that's why I'm doing that. And what I'll do is quickly I'll say train data generator is equal to data gen flow. Oh, this is our data gen train x comma train y comma batch size is equal to, have I mentioned batch size? Yes. Okay. So what I'm doing here is, the flow takes the data and label arrays and generates batches of augmented data. So finally we are here, and I'll say time. I'll just time it percentage time. History is equal to model dot fit train generator, which is this, comma validation data is our test x comma test y, and steps per epoch equal to length of train x by batch size, and we'll see epochs equals, yes, epochs, and I think we have it here. Oh, okay. Um, yeah, so it will take around, it will take 15 epochs to, um, to train, because that's what we have mentioned here. In the meantime, we'll just, continue with rest of the coding. So say um, equals, if you're wondering what history is, that's what we are training here. So, after training, we can print it and we'll see, what it is. History, um, loss, and validation loss is equal to, sorry, the validation loss, right? And we can say, okay, so if you're wondering what I'm doing here is I'm just, visualizing our, training and validation accuracies. So I'll just say plot one. Plot accuracy, and we'll give a title. We'll say training accuracy, right? Um, we'll just copy this, the same thing, and we'll do it for the, we did it for the accuracy, we'll do it for the training loss, right? We don't need loss, we need validation loss, and not accuracy, loss, and in the meantime, so what you can do is you can save the model also. You can say rps mob, um, v2 dot, uh, you know, you can save it, and you can also load it. So you can load, sorry, the procedure. So you can name anything whatever you want here, and finally, we can, we'll see, if we'll test it. So what I'll do is I'll just take this. instead of typing the whole thing, I'll just take this and what are the things we don't need here? Here we don't need the trigger, we don't need the counter, and you can add something like if red, if not, so break. So if it's not read properly, it will break. Else it will continue its job. So what I'll do here is cv2 dot and add something like cv2 dot. Here can name the window, named window rps. Um, what else I can do here? Don't this because we don't want any trigger. No, let's see the pointer region. So what I'll do is I'll just remove these. We just want a region of interest, right? We don't want anything else from that. So what I'll do is, so if you remember, had normalized it before, so we'll normalize it. Again, array 64. I think, yes, I think this should work. Yeah, 255.0. Because we are dividing everything. Spread is equal to dot. We need to predict. Now we are passing, because we're taking the region of interest and we need to, predict that. Say target index is equal to argmax. So, you just, do this to, get the index of the target class, and we'll get the probability also. Not what else can you do? I think dot. We'll put a text right out and say prediction. What I'll say here is give me up to two decimal values, right? Format full names inp.r max of. Okay, and we also need to print the probability. So probability will be from zero, like it will be from 0 to 1. So we'll just multiply it with 100. These are just the arguments, with the font style and, the starting index, font, okay, simplex, 0 point. We will put it in red color and give it some thickness to it, and what else? Oh, we need to show, right? Need to show for scissors frame, and yeah, we need to quit. We need to set it to key one. Sorry, okay. One if is equal to. So you know what's happening here, right? So we'll see if it's trained. Oh yes. Oh, 15 epochs is done. So it took something like 8 minutes to do it. We'll see. Uh, where is the history? Uh, oh, um, validation accuracy is not defined. It seems. Uh, Sprint. We have loss, accuracy, validation loss. Oh, it's validation accuracy. So I'm sorry about that. We'll do that. And validation accuracy also. Loss accuracy. Should be validation accuracy. 1 second. Yeah, sorry guys. So you can see that our training accuracy and validation accuracy increased, and our training loss and validation loss decreased. So I think we are pretty much good to go. You just need to put it in the codes. Let's not save it and load it. We already have it, so we'll just. The label names. Um, I'm sorry again. I'm sorry, it's just some syntax, small syntax is just pissing me off. Okay, so finally we have everything here. So as you can see in the top right corner, top left corner, you have prediction what in with what probability, what confidence value it's predicting. So let's go. Okay, paper, rock, scissors. We'll see what it. Oh, stop. It's toggling. Okay. Uh, Scissors, paper, paper. It's pretty still confident. Rock, nothing. Okay. So uh, we are, you know, mm, uh, you know, we have achieved it. So we are now you know able to predict whatever is in our region of interest from the help of our good internet friends, online friends. We were able to put the rest of the things together. So I'm really sorry. I'll just copy paste it and show it because we're running out of time. Rest of the things are these are pretty much self-explanatory because whatever we have done here, um, is the whole thing. Is it? Yes, I think so. Okay. Um, you can just this is pretty much the state. So if the user move is rock and computer move is scissors, so who's the winner? The user, right? So that's what it's doing here. And it's just showing the winner. I'm just taking some random images from my images folder and I'm just printing it. Yeah, it's and all these things are we just did it. That's pretty much self-explanatory for you. uh, I'm saying display computer move and you know it's whatever is doing it's randomly taking from the labels whatever we have given it, and that's what it's displaying here. um, so this is everything whatever we have done, everything put together. um, so what's our region of interest, and we are normalizing it. We are just predicting it, everything what we did. So we are just putting a threshold to probability value. If it is more than our confidence threshold, only then we'll go with the rest of the process. uh, so it's all these syntaxes should be familiar to you by now, because we used it like multiple times. And the same thing, when you press Q, it will exit. Let's see. Okay, let's start running these. Okay. Okay, I hope you can see this on the screen, whatever. So we are taking 5 atoms here, and we'll see, what it does. So I'll go with the rock. Computer is paper, rock. So computer one, the score is one, which you can see here. Um, so we have 4 attempts left. We'll go with paper. It's just that don't worry about it. It's just the random images I took. Like for rock, I took Dwayne the Rock Johnson. That's it. So it's a point for me, and I'll go with scissors. Okay, the computer chose rock again. I'll choose rock, and it took, and I went with paper. Choose paper. Oh, okay, so these are just the random images. If I have to tell you which function is executing this, this is what is executing this process. For winning, I took a random image. For if you win, it shows a random image. If computer wins, it shows another image. If it's a draw, it takes another image. You can just write out you win here and save it into a JPEG and rename it to you win, and you can win here, and so it will be more clear. Right now, I'm just taking the random images and it's just printing it. So if I have to play again, if I press enter, so it starts again here. Um, so I'll just because we don't need to go through this again, so I'll just press Q and I'll get quit from here. So this is mostly our most of our Um, yeah, this is the everything put together. The main part was for you guys to see how OpenCV works, and how to collect the data and how to train it using MobileNet version 2. So I think we pretty much clearly covered that. And the rest is you're piecing it together. You're bringing those two together and to form a game out of it. So don't worry. So I'll share the notebook here with you guys. I'll share the same notebook here with you guys. You can play around this. Instead of Adam, you can use stochastic gradient descent SGD, and you can play with it. You can increase the dropout. You can increase the dense layer. You can use a flatten or whatever you want here. You can just play around. With this notebook, and if you right now if you guys have any doubts, I'm happy to take the doubts now. You can now put it in the chat box. Oh, so you guys have. Oh, okay.
There don't seem to be any doubts. Is there anyone who has a doubt? Wants to ask something?
You can type it in the chat box, and I'll share the notebook also. You can play around with it. And later, if you have any doubts, please join Nowa Labs Facebook group. You can ask
Yeah,
ask us there. I will be very happy to help you guys.
absolutely. So let's wrap it up here. And thanks a lot, Nikhil. Thanks for the wonderful session and the game. We all enjoyed it a lot. And thanks everyone for joining. So our next webinar is on next Saturday, which is about price analysis of the Melbourne housing market. And if you're interested in joining, you can find the link on the chat. And it'll be great if you could share feedback for today's webinar so that we can keep improving and making it better for all of you. Thank you all for joining. And the Facebook group link, wait, I'll just post it again. So you can all join the Facebook group as well if you want to have discussion with others, other AI and ML enthusiasts. And that's it for us. Thank you, everyone. Thanks. Thanks, Nikhil.
Yeah, thank you, Varun.